morning children. Welcome to digital classes on TSAT. So here, today we are going to start the Physical Science chapter 1 in 10th class. Children, you all must have been very familiar with the concept of reflection of light at plane surfaces. Children, in this class, we are going to learn about the reflection of light at different surfaces. So let us see what they are. The reflection of light at curved surfaces. Children, in today's session, we will be learning about introduction to spherical mirrors. Observe the images before going into it. What do we see here, children? In the first image, you are seeing a big rock in front of a mirror. How is the image of the rock formed? The image is as the object is, as it is. Yes, children? Similarly, look at the kitten. The second image. There is a small kitten by the side of a plane mirror. How does the image of the kitten appear? The image of the kitten appears to be of the same size and as it is, except for the left to right inversion. Yes, children? We also look at ourselves in the mirror every day. Yes, children? And what type of image do we get in the plane mirror? We see an upright image exactly how we are, the same shape and the same size. So, this is the same plane mirror here. The only difference we get in a plane mirror is that the left to right inversion takes place. That is, our left side appears to be the right side and the right side appears to be the left side. Look at more images, children. Once again, you can see here the image of the pot here does not change as compared to the object. Observe the shape and size of the image. It is the same as the object. Similarly, the cylindrical object getting reflected in more than one mirror here, forming multiple images, also is of the same shape and size. There is no much difference. Yes, children, we can compare this to our image from our daily life. When we are talking about reflection, we can never forget the beauty of nature. You can see the reflection in nature, children. The water bodies, when they are still, that is, when they are not moving, behave as a perfect plane mirror. You can see the image of the trees and the mountains getting reflected. Similarly, the image of the boats with their stalks appear as it is inverted on the water surface. So, children, these are the reflection at plane surfaces that we have learnt in the previous sessions. Now, children, let us see what we are going to see the interesting phenomena in today's session. Observe this image, children. What do you notice? Is it the same what you see in your mirror? Or does it look a bit different? Yes, it looks a bit different. It is somewhat distorted. It is somewhat funny. If you see there on the left side, the image appears to be shortened on the top side and the legs appear to be long on the lower side. Similarly, the right side of the image, the top side appears to be elongated and the bottom side appears to be compressed. Actually, it is an image of the same person taking a photograph of himself. Okay, children. Now, what do you think is the reason for such a kind of image? Did you ever observe this, children? If you have ever been to the fun mirror houses in exhibitions and fun fairs, then you might have noticed that these images, the fun mirrors show these type of images. Yes, children. Now let us see the reason behind the formation of such kind of images. Children, this is our daily experience, our day-to-day life experience. The backside of a spoon, when you observe yourself at the backside of a spoon, from the backside of a spoon, how does the image appear? You can see the pencil here. The pencil appears to be distorted in shape, yes, and it appears to be thinner and it appears to be diminished in size or smaller in size. Yes, children? So, when you look at yourself on the convex side, even you also get to see the same image. This is the image of a pen on the front side of the spoon. On the front side of the spoon. How does the image of the pen appear to you? even you can look at the image of yourself placing the spoon very close to you. Okay children, keep it very close to yourself. So this image is magnified, that is bigger in size. Yes, it is bulged. We can say that it is bulged in size, and it is erected. That means the image is appearing as the object is. Okay children. Let us see one more image. Now, this image is different compared to the previous image. In the previous image, we saw the image was bulged, magnified and upright. But this image is inverted. This image appears to be what children? This image appears to be inverted. Yes children. Try to observe yourself in a new spoon. Keep it away from your face and your image appears to be inverted. Right? When we were kids, we used to laugh at such an image. Yes or no? Right. Now let us compare this to our subject. What do you see children? This is the image of a girl standing in front of a convex mirror. Okay children, this is the image formed by a convex mirror. How does the girl appear to you? The girl appears smaller in size, she appears to be more slimmer in size. Yes children, at the same time you are able to see so much area of the background also. The background area you are able to see, where you can see the 2 roads and so many trees also. Right children, that means the convex area is showing us a large view of the image. What about this image children? What do you observe here? Somewhat peculiar, right? Yes. Here if you see, there are 2 people standing in front of a big mirror. Observe the shape of the mirror children. The shape of the mirror appears to be like a bowl or a dish. Yes children, that is in front, the front side of the spoon. The image here is appearing to be inverted. Not just 1 or 2 people, you can see some number of people standing there whose images are formed inverted. Yes children. So this type of image is formed by a concave mirror. Okay, when you keep the object at a distance from the concave mirror, you see inverted images. Okay children. This was a similar case when you placed the pen very close to the spoon. Yes or no children? How did the pen appear to you? The pen appeared to be very bulged, very magnified, okay, very big in size, right? And look at the bulb now. If you see, the bulb here is appearing to be very, very big compared to the actual size. This is the actual bulb children, and this is the image of the bulb which is appearing to be magnified. Okay children, so when you place the object very close to the concave mirror, then the image appears to be enlarged or very big in size. Now children, let us come to our daily life observations. What do you see in the image children? Yes, the rear view mirror. Where do we use the rear view mirror? Yes, exactly, we use them in our vehicles, right? The driver uses the rear view mirror to observe the vehicles coming from behind. Okay, what is the purpose of this mirror children? The purpose of this mirror is to allow smooth driving and avoid accidents also. Okay, so it is helping the drivers actually to go for a smooth drive and a risk-free driving, right children? So this type of mirrors are used in all the vehicles that we drive. Next image children, have you ever been to the ghat roads children? If you have ever been to hilly areas or driving on a ghat road, you can see the U-pin bending of the roads. Yes children, if you see the ghat areas, you can see the U-pin bending of the roads. These roads are very risky because the driver on one side of the road cannot see the vehicle approaching from the other side. Use this convex mirror. This convex mirror placed such that the drivers on both the sides are able to see the vehicles coming from the other side. Okay children, once again, what is the purpose solved by this mirror? Yes, it is helping for a risk-free driving, especially it can be very helpful in the ghat roads. It is also used where there are a lot of turnings. Okay children, a lot of turnings on the roads. Let us see the next image children. Children, if you have been to any big malls or supermarkets in the towns or cities, then you might have seen such kind of mirrors. Yes children, you can see a mirror, a big mirror placed on the top of the shop. Okay children, what are you able to see in the mirror? In the mirror, we are able to see many items together. Okay, that means this mirror was placed by the storekeeper to observe the entire store sitting in one place. Children, these days we are making use of CC cameras everywhere. Okay, so the mirror serves the similar purpose. One glance at the mirror and the shopkeeper can see the entire shop. So this is called as the surveillance mirror. Children, all these are the types of or the uses of the convex mirrors. Let us see this type of mirror. Have you ever been to dentist children? Yes, scared of going to a dentist? Definitely. So when the dentist puts a spoon-like object in your mouth, you feel somewhat irritated, yes? So this spoon-like object is nothing but a concave mirror. Yes children, the circular object there, the circular object here is actually a concave mirror, right children? So you have seen in the spoon image that if you keep it very close to the object, if the object is kept very close, then you get a magnified image of the object. That means the dentist uses the concave mirror to observe your tooth decay very clearly. Okay children, so it is the concave mirror is used as the dentist's mirror. Next is the beautician's mirror, or also we can say the shaving mirror, right? So beauticians and barbers use the concave mirror to get a perfect shave or to get the perfect makeup done. Okay, when they are applying makeup or doing shaving to their customers, then they make use of this mirror to show their customers that the work is done perfectly. Right children, something we all can easily relate to, the dish antenna. What is the shape of this dish antenna children? Yes, it is in the shape of a dish. It is in the shape of a bowl. Okay, here children, what is the dish antenna doing? The dish antenna is receiving many electromagnetic signals. Okay, whatever signals we are receiving in the television is actually coming from the dish antenna. So the dish antenna receives the signals from space and these are transmitted to us through the receivers. The signals are sent into our television. One more application of the concave mirror, that is the headlights of the car. The headlights of the car use the concave shaped mirrors in the reflectors. Okay children, in the reflectors. In the reflectors, when the bulb is placed at a certain position, then the light rays can travel to a longer distance. Okay, the light rays can travel to a longer distance. At what distance? All this we can learn in our upcoming classes. So children, we have in our previous classes learnt about the laws of reflection obeyed by a plane mirror. Let us once review the laws of reflection for a plane mirror. So let us imagine this is a plane mirror and we will have a normal to the plane mirror. We will have a normal to the plane mirror. What is a normal children? It is a line perpendicular to the surface. It is a line perpendicular to the surface. Now, a ray incident on the surface of the mirror. A ray incident on the surface of the mirror is called as the incident ray, right? And the ray reflected from the surface of the mirror is called as the reflected ray. Okay children, so these are the incident ray, the normal and the reflected ray. Angle I and angle R. So I is the angle of incidence and R is the angle of reflection. The angle made by the incident ray to the normal is called as the angle of incidence, and the angle made by the reflected ray to the normal is called as the angle of reflection. Now what do the laws of reflection tell us? Do you remember children? Let us see them. Yes, the angle of incidence made by the incident ray with the normal to the mirror is equal to the angle of reflection. That is, angle I is equal to angle R. For a plane mirror, the angle of incidence is equal to the angle of reflection. That is the first law of the reflection, the laws of reflection. And the second law says the incident ray, the normal to the mirror and the reflected ray all lie in the same plane. Okay. Now these three different kinds of lines that we have seen, the incident ray, the reflected ray and the normal all lie in the same plane. That means they all will be in the same plane. They all are coplanar. They do not go and travel in the other plane. Okay, children. So these are the laws of reflection for a plane mirror. Why did we review this here? Because we have to know whether these are applicable to our new types of mirrors that we are learning. Yes, children. Now we are learning about the curved mirrors. What are they? The concave and the convex mirrors. So we want to see if the laws of reflection are applicable to the curved mirrors also. So let us see whether they are applicable or not. We will understand the normals for curved mirrors. Yes, children, it is not simple to understand the perpendicular lines. Yes, observe this foam sheet, children. Let us assume this foam sheet is a plane mirror and the sticks are the normals. We have inserted the sticks normal to the plane mirror. Okay, children. So this is a plane mirror surface and the sticks are normal to the surface. Normal to the surface. Yes, children. All these normals are parallel to each other. These normals are parallel to each other. Now let us bend it. What is happening? What do you observe? When we bend it forward, we see that the normals are converging and meeting at one point. Yes, children? This point is called as the center of curvature. This point is called as the center of curvature. This is a concave surface because it is bent inwards. This is a concave surface because it is bent inwards. The normals are converging and meeting at one point. This is called as the center of curvature. Now, what happens if we bend this backwards? Observe, children. What is happening if we bend the foam sheet backwards? What is happening to the normals? They are going away from each other. Yes, they are getting diverged from each other. They can't meet anywhere. But observe the back side. Observe the back side. The normals are extended backwards and they meet behind the mirror, which is called as the center of curvature. This point is called as center of curvature. So the convex surface is bent outwards. Okay, children? The convex surface is bent outwards. And the point is called as the center of curvature. Yes, children. I hope you all understood the video clearly. So here, very simple to remember. What do we mean by a cave? A cave means in Telugu we call it a guha. How it is? It appears like this, bent inwards. So it is a concave mirror, children. Okay? It is a concave mirror. Cave means bent inwards. Okay? And convex is bent outwards. Okay, children? So remember this terminology. Now let us see if the laws of reflection are applicable for curved mirrors also. Children, in this if you observe, the object is at O. The incident ray is OA. Okay, the incident ray is OA and the image is at I and the reflected ray is AI. The reflected ray is AI. AC is the normal. Okay, children, AC is the normal. We know that the line passing from the circumference of the mirror to the center of curvature is the normal. So we see that the incident ray as well as the reflected ray are making the same angle, Okay, children? So that means we can say the laws of reflection are applicable for curved mirrors also. Okay children, you can see here AC is the normal and the incident ray OA and the reflected ray AI are making equal angle with the normal AC. Okay, so the first law of reflection is satisfied. Also you can see the incident ray, the reflected ray and the normal all are in the same plane. So very clearly we can say that the laws of reflection are applicable for curved mirrors also. Having understood this concept children, let us go into understanding more important concepts, that is the terminology related to the spherical mirrors. Okay children, so it is the geometric center of a spherical mirror. The pole is defined as the geometric center of the spherical mirror, or we can also say that it is the exact midpoint of the spherical mirror. So if you have a mirror, then the exact midpoint of the mirror is called as the pole of the mirror. Okay children, the exact midpoint of the mirror is called as the pole of the mirror. This pole actually lies on the mirror children. This pole actually lies on the mirror and we can easily identify it, unlike the other terms that we are going to learn. Okay children, so it is the geometric center of a spherical mirror, or it is the midpoint, the exact midpoint, just like the center of a circle. Okay, just like the center of a circle, the pole is the midpoint of the spherical mirror. Now let us define center of curvature that we have seen in the previous video. What do we mean by the center of curvature? The point where the normals of the curved mirrors intersect is called the center of curvature. This is what we have seen in the activity children, the foam and sticks activity. The point where the normals of the curved mirrors intersect is called as the center of curvature. This can also be understood as the center of a big imaginary sphere from which the mirror was taken. Okay children, it can also be understood as the center of the big imaginary sphere from which the mirror was taken. Now let us define the radius of curvature. So children, you also know what do we mean by radius. Radius means the distance between the center of the circle to any point on the circumference. So here we will be applying the same concept. The radius of curvature of a spherical mirror is defined as the distance between the pole of the mirror and the center of curvature. Okay children, the radius of curvature is defined as the distance between the pole of the mirror and the center of curvature. So children, let us try to understand these things in a better manner. Imagine this to be a big spherical ball. A part of it is taken. This is the spherical mirror. Okay children, this is the spherical mirror. Now the exact midpoint of this mirror is the pole of the mirror. The exact midpoint of the mirror is the pole of the mirror. Okay children, the line passing through the pole of the mirror, the line passing through the pole of the mirror is called as the principal axis. Yes children, the line passing perpendicularly through the pole of the mirror is called as the principal axis. Now the center of this sphere, from which the mirror was taken, the center of this sphere from which the mirror was taken is the center of curvature, of the spherical mirror. Okay children, it lies on the principal axis. Okay children, and the distance between the pole of the mirror to the center of curvature is called as the radius of curvature. Okay children, hope you have understood the pole of the mirror and the center of curvature. So from these two we have defined the radius of curvature. The radius of curvature is the distance between the pole of the spherical mirror and the center of curvature. Children, let us see a small activity to understand the focus of a concave mirror. let us take a concave mirror and place it in a stand. Now, focus this mirror towards sunlight or any distant object. Put a screen in front of the mirror and try to capture a perfect image, a clear image for the mirror. Okay children, you can see that a clear image of the object is formed. The object has to be at a long distance, either sun or any other object. You can see that a clear image of the object is formed at a certain distance. Now, let us measure the distance. The distance is approximately 20 centimeters. Okay children, the image is getting focused. So, where the light rays converge and meet, where the light rays are converging and meeting at a point is called as the focus of a concave mirror. Now, let us define the focus of a concave mirror and convex mirror children. The point on the principal axis of a concave mirror where the reflected rays converge and meet is called as the focus of the concave mirror. Okay children. So, light rays coming from infinity are parallel to the principal axis, and after reflection they all meet at the focus of the mirror. This is the focus of a concave mirror. Focus of a convex mirror. Light rays coming from infinity are parallel to the principal axis. After reflection, they are diverging from each other. They are getting diverged from each other. So, when we observe, it appears as if the light rays are coming from a point behind the mirror. So, this is called as the focus of the convex mirror. This point is called what children? The focus of the convex mirror. Let us understand what is the focal length. The focal length is the distance between the pole of the spherical mirror and the focus. The distance between the pole of the spherical mirror and the focus, that is where the image was formed, is called as the focal length of the mirror. This is suitable for both concave and convex mirrors. The focus lies exactly in between the pole and the center of curvature. What does it mean children? The focal length is exactly half of the radius of curvature, or we can write r is equal to 2 into f, or f is equal to r by 2. Important relation between focus and the radius of curvature. This is the mirror, the principal axis, pole, center of curvature, and the focus lies exactly in between. So, we have come to the end of the session. Before concluding, let us see what we have learned today. So, we have learned two types of spherical mirrors, concave and convex. The reflecting surface in a concave mirror is bent inwards and it is called as a converging mirror. The reflecting surface in a convex mirror is bent outwards. It is called as a diverging mirror. The laws of reflection for a plane mirror are applicable to curved mirrors also. And about the terminology, the geometric midpoint of the spherical mirror is called pole. The line passing perpendicularly through the pole is called as the principal axis. The point on the principal axis where all the normals of the curved surface intersect is called as the center of curvature. And the distance between the pole of the mirror and the center of curvature is called the radius of curvature. The point on the principal axis of a concave mirror where the reflected rays converge is called as the focus of the concave mirror, and the point on the principal axis of a convex mirror where the reflected rays appear to meet behind the mirror is called as the focus of the convex mirror, and the distance between the pole of the mirror and the focus is called the focal length. Okay children, so these are the important points that we have learnt today. These are some questions to improve your learning. Children, please make a note of these questions. Discuss the various parameters connected to the spherical mirrors. Write the differences between concave and convex mirrors. Discuss your experience of using any spherical mirrors with your friends. How are radius curvature and focal length related? And a small numerical problem. If the center of curvature of a concave mirror is situated at 44 centimeters, then find the focal length of the mirror. It is a very simple problem children. You can use the formula f is equal to r by 2. Okay children, I hope you all have understood the concepts that we have discussed today, and I hope you are looking forward to the next session where we are going to see the demonstration of a lab activity and also an important concept, the ray diagrams. Thank you.